Imagine a red sky as the backdrop, where humanity takes its first steps on an alien planet. This is not merely a science fiction fantasy, but a future that is drawing ever closer. Mars, the mysterious red planet, has been the focus of humanity's dreams, studies, and ambitions for decades. The possibility of establishing a colony on Mars is not just a technological or scientific milestone, but a unique opportunity to rethink how we live, consume, and coexist. And, ironically, it teaches us to better care for the only home we currently have, Earth. Today, we will explore how the sustainable colonization of Mars can offer valuable lessons for the survival and prosperity of our own planet. To fully grasp the complexity of this endeavor, it's crucial to understand that Mars offers none of the comforts that sustain life on Earth. There is no liquid water readily available, and any attempt to extract water from Martian ice will require advanced technologies and significant energy consumption. Additionally, Martian soil, laden with toxic perchlorates, is completely unsuitable for agriculture without intensive chemical treatment. Every aspect of human survival, from oxygen production to radiation protection, will depend on highly specialized and resilient systems operating with uninterrupted precision. This hostile environment forces humanity to think outside the box, to innovate, and to develop solutions that not only enable survival on Mars but also revolutionize how we address environmental challenges on Earth. Moreover, the challenge of managing water on Mars compels us to rethink not just technology but also our cultural relationship with this vital resource. On a planet where every drop must be painstakingly extracted and recycled countless times, waste will not be an option. Imagine the impact of these technologies and this mindset if applied on Earth, particularly in regions where water scarcity is already a critical issue. Efficient recycling systems, like those designed for Mars, could transform arid areas into habitable and productive hubs. At the same time, developing methods to extract water from untapped sources, such as atmospheric moisture or subterranean ice, could provide innovative solutions to global water crises. Mars teaches us that water, though abundant on our planet, is a precious resource that must be treated with respect and a long-term vision. Beyond greenhouses, another fascinating possibility lies in using biotechnology to genetically modify plants, making them more resilient to extreme conditions such as low gravity, artificial lighting, and nutrient-poor soils. This could pave the way for cultivating more nutritious foods that require fewer resources to grow, both on Mars and Earth. For example, scientists are already studying microorganisms and fungi that can be used to create more fertile soils or even serve as direct sources of edible protein. On a planet like Mars, where every gram of food will need to be produced locally, these innovations could reduce reliance on external supplies. On Earth, these same technologies could help combat food insecurity in vulnerable regions, revolutionizing access to food in areas with challenging growing conditions. What we are developing for Mars is not merely a solution for space, but a promise to fight global hunger. Energy is another crucial issue. Mars has no fossil fuels. We will rely almost entirely on renewable sources like solar energy. However, the sunlight reaching the red planet is weaker, requiring ultra-efficient solar panels. Additionally, energy storage will be vital to survive the long Martian nights, which last over 12 hours. This means developing extremely high-capacity batteries or new storage systems. Imagine the impact of these technologies on Earth. They could solve the intermittency problems of renewable energies like solar and wind, bringing clean, affordable electricity to remote and underdeveloped regions. Another fascinating aspect is the concept of sustainable habitats. Any colony on Mars will have to be self-sufficient, as relying on supplies sent from Earth would be economically unfeasible and logistically risky. This means building habitats capable of generating their own resources: energy, water, oxygen, and even construction materials. Research is already underway to use local Martian resources, such as turning atmospheric carbon dioxide into oxygen and manufacturing bricks from Martian soil. Now, imagine applying these ideas on Earth. Cities that generate their own energy, recycle their own waste, and use local materials for construction, drastically reducing carbon emissions. Sustainability in the colonization of Mars also involves the challenge of maintaining an ecological balance in an artificial environment. Scientists will need to create closed ecological systems where plants, microorganisms, and humans coexist in harmony, recycling nutrients and keeping the air breathable. This is something we completely neglect on Earth. Here, we continuously break ecological cycles, pollute our oceans, and destroy forests that regulate the climate and produce oxygen. Mars will force us to rethink how we interact with ecosystems, teaching us that survival depends on respecting and maintaining these cycles. But perhaps the greatest lesson Mars can offer is about simplicity and efficiency. There will be no room for waste, unnecessary luxury, or rampant consumption. Every object, every gram of material will need to have a well-defined function. This minimalism, driven by necessity, could teach us to reevaluate our lifestyle on Earth. Instead of accumulating disposable goods, we could learn to value durability, functionality, and repairability. There's also the psychological aspect. Life on Mars will be solitary, confined, and challenging. Colonists will need mental resilience to cope with isolation, repetitive routines, and the absence of nature as we know it. To address this, scientists are exploring ways to create indoor environments that mimic nature, using lights that simulate sunlight, indoor gardens, and even artificial sounds of forests and oceans. This prompts us to reflect on how essential our connection to nature is for mental health here on Earth. Shouldn't we value more the parks, forests, and oceans we still have? However, the colonization of Mars also comes with a warning. If we fail to learn these lessons, we risk turning Mars into a reflection of the same mistakes we've made on Earth. Expanding to another planet without solving our issues of overconsumption and environmental destruction would merely transfer the problem elsewhere. This is Mars paradox. It offers us the chance to start anew, but also confronts us with the consequences of what we've done to our home planet. Ultimately, Mars is not just a destination. It is a mirror. It shows us what we are capable of building and destroying, inventing and preserving. Every technology developed to survive there is a tool to save Earth. Every step we take toward the red planet is also a step toward a more sustainable future here. So, when we look up at the night sky and see that small red dot shining, we are not just seeing a distant planet. We are seeing a promise. The promise that, if we learn from our mistakes and apply our innovations responsibly, we can not only colonize Mars but also rediscover how to live sustainably on our own world. Because in the end, Mars' greatest lesson is this: our future depends on how we choose to care for what we have now.